Good morning, students. We are now in our second lesson on elementary and intermediate algebra. And our lesson is about writing numbers from the standard form to scientific notation and vice versa. So let's define first what is a scientific notation. So here, scientific notation is a standard way of writing a very large or a very small numbers so that they are easier to both compare and use in computation. It is also a method of writing numbers as the product of two factors, where the first factor is a number greater than or equal to 1, but less than 10. And the second factor is a power of 10. Okay, now every number in the scientific notation must be in the form of a times 10 raised to the n. And where a is greater or equal to 1, but less than 10. And n must be a positive or a negative number, the n here or the exponent. So writing numbers in the scientific notation, let's have case 1. If the non-zero digit comes first before the decimal point. Example, we have here 250,000. The second case, if the decimal point comes first before the non-zero digit. Example, we have here 0.00095. Okay, so we have to write in scientific notation, let's have the case 1. A times 10 raised to the n. We have here 250,000. So, if the non-zero digit comes first and the decimal point comes next, what shall we do? We move the decimal point to the left. And n should be a positive integer. The n here, class, would be the number of movement of the decimal point. Okay, let's have the example. Write the given number in scientific notation, 250,000. Here, we don't find the decimal point in 250,000. It is understood that there is a decimal point at the end. There. So, in this number, the non-zero digit comes first and the decimal point comes next. So, we have to move the decimal point to the left. Okay. So here, the number of digits between the first non-zero digit and the decimal point is 5. So the decimal point has to move 5 places to the left. That is, we have to do it 1, 2, 3, 4, and 5. It is moved to the left. Here. 1, 2, 3, 4, 5. And so, we will have here an answer of 2.50000 times 10 raised to the 5th power. Therefore, the scientific notation of 250,000 is 2.5 times 10 raised to the 5th power. Why? We need not write here the zeros, 1, 2, 3, 4, the 4 zeros, since they are already non-significant figures. Okay. Next, example number 2. Write the given number in the scientific notation. We have here 7 million. So the understood decimal point is at the end, right? So we move the decimal point to the left. How many times? 1, 2, 3, 4, 5, 6. So there. So our final answer is 7 times 10 raised to the 6. Here, the 7. The zeros here is already removed since they are now non-significant figures. Okay. Try this. Write the following numbers in scientific notation. 75,000. We now have an answer of 7.5 times 10. So the understood decimal point here is at the end. So 1, 2, 3, 4. So we write there 7.5 times 10. Why 4? It is 4 places to the left. Okay, next 900. So what's your answer? It's 9 times 10 raised to the second. That is 1, 2. There we have it. Next, 850,000. What's your answer? It would be, we write 1, 2, 3, 4, 5. So our answer is 8.5 times 10 raised to the 5th power. Next, 725 million. What's your answer? Let's see if it is correct. Okay, it is 7.25 times 10 raised to the 8. We'll do it together. The understood decimal point is here. So 1, 2, 3, 4, 5, 6, 7, 8. And we write there 7.25. We don't need to write the other zeros, the 6 zeros, since it is insignificant figures. And the next now is for the case 2. And the form will always be 8 times 10 raised to the n. So we have here an example, 0.00095. So if the decimal point comes first here, then the non-zero digit comes next. So what shall we do? We have to move the decimal point to the right this time. And n, remember your n will be a negative integer. Okay, let's have the example, 0.00095. In scientific notation, it is obvious that the original decimal point is to the left of the non-zero digit. So we will move the decimal point going to the right. The rule above states that when the decimal is moved to the right, the count of the exponent of the base 10, okay, will always be, put that in mind, negative. Okay, so let's have this. We now move. The decimal point comes first, then zero. So we now move to the right. How many times? 4 places. Okay, there. 1, 2, 3, 4. It's only here. Okay, so the final answer will be 9.5 times 10 raised to the negative 4. Let's have example 2. Write the given decimal of this, 0.00000000086 in scientific notation. So maybe you can predict that since the given decimal number is between 0 and 1, we should have a scientific notation with a negative power. Okay, remember that. First, identify the initial decimal point and where it is going. Here, it is here. So we go to the right. How many times? We count together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so, Our answer, it is moved 10 times to the right. So, the answer will be 8.6 times 10 raised to the negative 10. Okay, since we moved to the right. Okay. Now, example. Let's have this 0.00072. Next is 0.0000625. 3, 0.009, and number 4, 0.746. So, let's check your answer. So here, we now have an answer for number 1. Why negative 6? Let's do it together. 1, 2, 3, 4, 5, 6. So it is 7.2 times 10 raised to the negative 6. For number 2, it is 1, 2, 3, 4, 5. So we now have to write 6.25 times 10 raised to the negative 5. Next, 0.09, we move 1, 2, and 3. So we now have 9 times 10 raised to the negative 3. And for number 4, we move only 1. That is 7.46 times 10 raised to the negative 1. Why? If we move 2, what would be our answer? It turned out to be 74.6. So that is greater than 9 already. Okay, so it's only 1. Okay, what about the vice versa of this? Writing numbers from scientific notation to standard form. Case 1, if the scientific notation has a positive power, the standard number is greater than 1. And we have to move the decimal point to the right. Your answer here will be a very large number. Okay, if we are to have a positive power. Okay, let's have this example. 8 times 10 raised to the 4th power. Okay, the solution would be, it is understood that 8 will have the decimal point at the end, right? So, 8 is written as 8.0. Okay, now, since the exponent here is positive 4, so we move now to the right. How many times? 4 places. So 1, 2, 3, 4. So our final answer is 80,000. Okay, let's have example number 2. 7.25 times 10 raised to the 6. Well, here 7.25 understood the decimal point is between 7 and 2. So the exponent is 6. So we now move to the right 6 places, right? Okay, so we move. So here, 1, 2, 3, 4, 5, 6. There, with the arrow. So the final answer, we will have 7,250,000. Okay, that's the standard form. Okay, let's have the case 2. If the scientific notation has a negative, you look at this, power, the standard number is less than 1. Move the decimal point to the left. The standard number, I repeat, is less than 1, or meaning to say, a very small number. And the movement of the decimal point is to the left. Let's have the example. 8 times 10 raised to the negative 2. So, here, the exponent is negative 2, and 8, the understood decimal here is at the end. So, there we have it. So, here it is. We move it now to the left. How many places? Since the exponent is negative 2, so there. So 1, 2. There. So our answer is 0.08, or this could be read as 0 and 8 hundredths with a TH. Okay, that's example 1. Let's have example 2. 4.75 times 10 raised to the negative 5. So here, the exponent here is negative 5. So the decimal point is there. So we move it to the left. How many times? 5 places. So there you have it. So 1, 2, 3, 4, and 5. So our final answer in the standard form of 4.75 times 10 raised to the negative 5 is 0.0000475. Okay, try this. Number 1, 1.75 times 10 raised to the 4th. The exponent is positive. Number 2, 7.2 times 10 raised to the 5th power. The exponent is positive 5. Number 3, 4 times 10 raised to the 7. The exponent is positive 7. Number 4, 9 times 10 raised to the negative 6. Negative 6 is the exponent. And for number 5, 4.125 times 10 raised to the negative 3. Negative 3 is the exponent. So, let's do it together. Let's check your answer for number 1. Okay, did you get it right? So, your answer is 17,500. So, we move 4 places to the right. So, there. Number 2, 7.2 times 10 raised to the 5th power. What's your answer? It would be 720,000. Next, 4 times 10 raised to the 7th power. What's your answer? Okay, it is 40 million. Very good. Did you get it right? Okay, good. Next, 9 times 10 raised to the negative 6. Negative 6. What's your answer? Okay, it would be 0.000009. You will be having here 5 zeros after the decimal point. Did you get it right? Okay, good. And for number 5, 4.125 times 10 raised to the negative 3. Final answer is 0.004125. Okay, we got 5. Excellent. 4. Very good. 3. Good. 1 and 2, you may have to repeat this digitalized lesson. And for that, thank you for watching. Please like and subscribe. Goodbye.